All right. Hello, students. How are you all? Still nobody came. I'm not finding any charts on that, but 3 members are ready for watching, I hope. All right. And today, yesterday, because of your request, I was not able to take the class, and today I'm going to take the class. Okay. And today we are going to complete this chapter, continuity and differentiability. Okay. So let's check where are remaining people. Let them come back so that we start our live. I'll give some 2 minutes, after that I can start. Okay. All right. Only 4 are present. Priyanshi, Shubham, Akshit, Jinisha. Good afternoon. And what about reminder? Now only I have to start now. So I was checking here. Numbers need to increase. Only 3 or 4 means what is use of starting our life? Priyanshi, good afternoon. Yes. 4 are there. Where is Himanshu, Kirtan? So check those all students and then let me start. So if you want early to complete, you have to come early. So till now here reached only 4 students, 5 students. Where is Divyanshu? Divyanshu need to come now regularly. Tanish. Tanish also missed. Right now it is already 4 minutes completed. Then let me start our class. Before going to our class, let's close our eyes and then we'll pray. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. All right, we discuss exercise number 6.25. So we have to complete today this full exercise. Okay. So Satish, you just inform to your friends and then everyone come and join. And now 13 members are there. You already know that I'm going to reduce your timing if you are properly coming. So now exercise number 6.2. In that, now we are going to discuss Fifth one. Examine the function for the differentiability at x is equal to 0 and f of x is equal to x tan inverse x if x is not equal to 0. 0 if x is equal to 0. So very simple. Just observe carefully what is our differentiability. So when this function is going to be differentiable, if a left hand derivative is equal to right hand derivative, then we can say that these both are equal, then it is a differentiable. Okay. Tanish Jain, good afternoon, but still students are left. Okay. Need to come still. I think 4 members need to come still. After that, it is going to be complete. Okay. So now what we need to do here, it is solution for this at x is equal to 0, f of 0 means at x is equal to 0, what is your function? Function becomes as 0. So that f of 0 is nothing but 0. Okay. So good afternoon, Digyanshu. Yes, good. So 11 reached, then 2 more left. So f of 0 is equal to 0. That is equation number 1. And what is your left hand derivative formula? You already know that limit h tends to 0. F of a minus h minus f of a upon minus h. This is your left hand derivative formula. So now what we need to do is wherever a is there, substitute 0. Okay. Right. So now here this is equal to limit h tends to 0. F of a minus 0 is 0 minus h. So f of 0 minus h minus f of a. A means here 0 minus h. That is equal to what can I write? Limit h tends to 0. F of 0 minus h means minus h. So wherever your x is there, you have to substitute minus h. Only 9 are there. So still 4 need to reach. Okay. Right. Tanish already solved this, but you can concentrate here remaining. So x place here minus h substitute minus h tan inverse x means again minus h. Because 0 minus h means we'll get as minus h minus f of 0. F of 0 we found as how much? 0. So that we need to keep as 0 upon minus h. So now what we'll write here? This is equal to limit h tends to 0 minus, see here minus 0. See, any number is subtracted with 0, you get a same number. So we can write this as minus h tan inverse minus h upon minus h. Minus h get cancelled. Limit h tends to 0 tan inverse minus h. Now remove this limit. Wherever h is there, substitute 0. So now you get as tan inverse minus 0. Minus 0 plus 0, whatever it is 0. So now we can write here it is tan inverse 0. That is equal to tan inverse 0. When it will come in tan inverse, it is a tan 0 time. So tan and tan inverse get cancelled. That is equal to 0. So this is your equation number 1. Yes, good afternoon. Tanish, what are you asking Tanish? F of 0 differentiable? No. See, it is LHD equal to RHD and then only we can say that as a differentiable. Otherwise, no. Okay. So, again, reach. So, you have to increase the members. Members can. So RHD is equal to, we can write limit h tends to 0, f of a plus h minus f of a upon h. So now we can write here f of a plus h means that is limit h tends to 0 at x is equal to 0, so that a is equal to 0. So now we can write f of 0 plus h minus f of 0 plus h means h. So wherever x is there in this, substitute as h. So then we can write h tan inverse h minus 0, because f of 0 h tends to 0, h tan inverse h upon h. H get cancelled. So now remove limit, apply your 0. So tan inverse h plus 0, that is tan inverse 0 means we already found that as 0. Directly you can write it as 0. That is equation number 2. So at last write, therefore from 192 LHD is equal to RHD. Therefore, f of x is differentiable at x is equal to 0. Understood now? Both LHD and RHD both are equal, then only we can say these all differentiable, otherwise it is not at all differentiable. Okay, so that is about that. And where is this Himanshu? Today Himanshu was not set present, sir, and Kirtan also not set, so check them. So that is about your fifth problem. Anyone having any doubt, you can inform to me. Satish, take care of your boys, and Jinisha, you check all girls are present or not, Deepal present or not, check those all. All right, now this is sixth problem. Now we are going to solve. So now sixth problem. What is there? They given in the sixth one. Examine the function f for differentiability at x is equal to 0. So now first we need to write here at x is equal to 0. And what is your function? F of x is equal to 1 minus cos x upon 2 if x is less than or equal to 0. X minus 2x square upon 2 if x is greater than 0. So now here it is, what is your LHD? What is your RHD? So less than is there means that is going to be your LHD. Greater than is there means that is your RHD. So left hand derivative and right hand derivative. So now these both, if we are able to show equal, then it is going to be differentiable at x is equal to 0. Otherwise, it is not differentiable at x is equal to 0. Okay. So that is about that. And now we are going to solve this problem number. We are going to solve this problem number 6. Okay. So now first we'll go for our f of 0. F of 0 means here equal to 0, here it is. So that this function you have to use 1 minus cos x plus you need to substitute now 0. So cos 0 upon 2. 1 minus cos 0 is nothing but 1 upon 2. 1 minus 1, 0 upon 2, that is nothing but 0. So you got f of 0 as 0. Okay. So after that, what we need to do? So we need to go for left hand derivative, that is equal to limit h tends to 0 f of, here a is 0, so directly I am writing 0 minus, this is your formula, and limit h tends to 0, f of 0 minus h means minus h. So left hand derivative means this is your equation, wherever x is there, substitute there minus h. So now we can write here it is 1 minus cos of minus h upon 2 minus f of 0 is nothing but 0 upon minus h. You already know that cos minus theta, this is here I am writing cos minus theta is equal to cos theta. So cos of minus h means we need to write as cos h. Okay. Okay. So now here we can write limit h tends to 0. So now we can write this as 1 minus cos h. So we'll write this. After that, now 1 minus cos theta is nothing but 2 sine square theta upon 2. Remember this. 1 minus cos theta is equal to 2 sine square theta upon 2. Remember that formula? And then we need to apply here. So when you apply, what we are going to get? So this is limit h tends to 0. This we can write 2 sine square h upon 2. That is upon minus 2h. 2 and 2 get cancelled. So now what we are going to get? That is equal to limit h tends to 0. It is for fluctuating between 9 and 10 only. Priyanshi is present and Janisha is present. Okay. Where is Trapti? Trapti is present or not? People present or not? You check that. Okay. Limit h tends to 0. Sine square h upon 2. We can write here sine square h upon 2. Can I write sine square h upon 2 as sine h upon 2 whole square? Yes, we can write. After that, here what is there? Only h is there. But I want here, h is there, we could not solve this. Here square is there, so that here I want h upon 2 whole square I want. So the first what I need to do here it is, this should be into h upon 4. So I was multiplying with into h upon 4 and here also numerator also into h upon 4. So why I was multiplying you can understand here, okay? Prapti is not there, people also. Okay, Priyanshi. So now here it is numerator being multiplied with h upon 4 and denominator also multiplied with h upon 4. Why I was multiplied you can understand here now. So here limit h tends to 0. Now here h into h square. So now we can write this sine h upon 2 whole square upon this h into h square. 4 we can write as 2 square so that we can write h upon 2 whole square. So then you are going to get sine h upon 2 upon h upon 2 is nothing but 1. So into what is left here? H upon 4. Now give limit to the both. Limit h tends to 0. Sine h upon 2 upon h upon 2 whole square into limit h tends to 0 h upon 4. So now what we need to do? Just we need to substitute this value is nothing but limit h tends to x tends to 0 sin x upon x is equal to 1. By using that, this full becomes as a 1 into limit x tends to 0 h upon 4. Remove limit, apply that 0 upon 4. That is 1 into 0, that is nothing but 0. So in this way, we'll get LHD. Okay. So now f of 0 we got, LHD we got as 0. Then we need to go for RHD. If RHD also means right hand derivative also, if you get 0, it is differentiable at x is equal to 0. If some other answer if you get, then we could not. Okay. So that is about that. Where is Divyanshu? Shubham, okay, he came and gone. It is very bad. Okay, I will take care of him. All right, now we are going for next. That is RHD. Now, right hand derivative we are doing. So now RHD is equal to, so here it is limit h tends to 0. So what is your formula? F of 0 plus h minus f of 0 upon h. So now right hand derivative means our function is this. In this place wherever x is there, substitute your h. 0 plus h is nothing but h. You just substitute that h, okay? So now we can write here limit h tends to 0. Here we can write h minus 2h square upon 2 minus what is f of 0? So we found f of 0 as 0, so we'll write 0 upon h. So now that is limit h tends to 0. 0 is subtracted with any number, we get a same number. So now h minus 2h square upon 2 upon h. So this we can write it as limit h tends to 0. In both common h, when you common h, 1 minus 2h upon, here it is 2 into h, 2h. So now here h get cancelled. So what you are going to get when h is get cancelled? What is your limit now? So that is equal to limit h tends to 0. So 1 minus 2h. So now here 1 minus 2h upon 2. This only left. So now what we need to do? Limit remove, and wherever h is 0 now. Okay. So now here it is, we can 1 minus 2 into 0 upon 2. So that is nothing but half. So Divyanshu, don't come and go. You just stay like that only. Okay. So now here it is equation number 1 you got, means LHD you got as 0 and RHD you got as half. Is these both are equal or not equal? So we know that it is not equal. So now we can write here this is equation 1 and this equation 2 from 1 and 2. LHD is not equal to RHD. Therefore, f of x is not differentiable at x is equal to 0. Clear now? So, LHD you got as 0, RHD you got as half. These both are not equal, so that we can say that f of x is not differentiable at x is equal to 0. Okay? You all understood this? Directly LHDs are so long, sir. We can write directly 2 into 0 upon 0. It is possible, but the thing it was we need to use this formula, that is a sine x upon x. Because of that reason we went. Okay. Right. Next. No doubts are clear. Okay. So now we are going to the seventh problem. Seventh problem is a good problem. So you can you need to understand that clearly. 7th and 11th are important problems. Okay, 7th and 11th problems are important problems. Now we are going to solve our 7th problem. Okay, show that the following function f of x. So show that following function f of x is equal to x power n cos 1 upon x and 0 when x is not equal to 0, when x is equal to 0. So this is what they given function. First one, a is in that continuous at x is equal to 0 if m is greater than 0, and b differentiable at x is equal to 0 if m is greater than 1. So this we need to prove. How to prove? Observe carefully so that you can understand this. You know, continuous means already know that is LHL and f of 0. So it is at x is equal to 0. So here f of 0 is equal to LHL is equal to RHL happened. Then it is continuous. And differentiable at x is equal to 0 means you need to prove in that place it is LHD is equal to RHD is equal to some answer. So those all should be equal. So let me go for first one, A, continuous. Continuous at x is equal to 0. So how to prove that? So it is prove that continuous at x is equal to 0. So now first f of 0. You know that at x is equal to 0, our function is 0, so that f of 0 is nothing but 0. So this give as equation number 1. And next one it is our LHL, left hand limit. That is limit h tends to 0, f of a minus h. A means here 0. So just write limit h tends to 0, f of 0 minus h. 0 minus h means you get as minus h. So this minus h you have to substitute in your limit. So you know that left hand limit means that is going to be your x is not equal to 0 function. That is x power m cos to the power cos 1 upon x. X plus we need to substitute minus h. So limit h tends to 0 minus h whole power m cos 1 upon x means minus h. Substitute that minus h. You already know that in this cos minus theta is nothing but cos theta. So that means cos of minus 1 upon h means cos 1 upon h. So now you can write this as limit h tends to 0 minus h whole power m cos 1 upon h. So now here what I am doing is remove limit and substitute 0. So minus 0 means 0, 0 power m into cos 1 upon 0. So cos infinite means again it is not at all defined. But here this value is 0 happens, 0 into any number we get as 0. So if this value need to be 0, this m should be greater than 0. So that's a if m is greater than 0, then what will happen? So it is 1. Greater than 0 means 1 takes. 0 power 1, 0. 0 into any number, 0. 0 power 2, 0. 0 into any number, 0. So now at last, if m is greater than 0, then we can write this as equal to 0. If m is greater than 0, anyhow, I think you are not finding that. Let me keep. Yes. So now here, if m is greater than 0, this whole becomes as 0. Otherwise, it is not going to be a 0. So that is about that. So now we can go for our right hand limit. So right hand limit is equal to limit h tends to 0. Now I'm going for direct, okay? F of 0 plus h. So now wherever x is there, you need to substitute only h. So when you substitute h power m into cos 1 upon h. So now here it is limit h tends to 0. So now what I do is just remove limit, substitute 0. 0 power m cos 1 upon 0. So that is equal to if m is greater than 0, this whole becomes as 0. So now this is given as equation 2, this is given as equation 3. From 1, 2 and 3, f of 0 is equal to f of 0 minus 0 is equal to f of 0 plus 0. Therefore, where m is greater than 0, therefore f of x is continuous at x is equal to 0. I hope you all understood how this continuous happened. Anyone having any doubt in this? I hope clearly it was step by step I was explained this. Anyone having any doubt in this A? If no doubt, I'll go for B, differentiable at x is equal to 0. Tell to me fast. Oh, it reached to 7 again. See, likes are more than that. What was this? Who is missed? Those students kindly come first. No doubt, sir. Okay, Divyanshu, what happened? No, okay. No means then we can rub this part and we'll go for differentiable. Right. So now we need to check differentiable at x is equal to 0. So now differentiable at x is equal to 0. So that I need to prove that differentiable at x is equal to 0. First f of 0 is equal to 0. Next one, left hand derivative. What is formula of left hand derivative? Limit h tends to 0 f of a minus h minus f of a upon minus h formula. But at x is equal to 0 means wherever a is there, substitute 0. So now limit h tends to 0 f of 0 minus h minus f of 0 upon minus h. So now observe carefully. Wherever here my x is there in this place, substitute minus h. When you substitute minus h, what will get? Limit h tends to 0. Substitute here minus h whole power n cos 1 upon minus h. Like previously what we done, same method. F of 0 is nothing but here 0, so keep 0 minus h. So this is equal to limit h tends to 0. Anything separated with 0 will get same number. So now here minus h, here also minus h is there. So we can write minus h whole power m minus 1, because you know that a power m upon a power n is equal to a power m minus n. So by using this formula, we written this minus h whole power m minus 1. After that, cos minus 1 upon h becomes as 1 upon h, because you know that cos of minus theta is equal to cos theta. So by using that we written. Now remove this limit, apply what you get. Apply 0. So then wherever h is there, 0 substitute. So minus 0 whole power m minus 1 cos 1 upon 0. Same method. Minus 0 means 0 only we have to consider 0 power m minus 1 cos 1 upon 0. When here m is there, m is greater than 0. M minus 1 is there. So m minus 1 should be greater than 0. So if m minus 1 is greater than 0, then this whole becomes as 0. So then m minus 1 greater than 0, we can write it as this plus minus 1 go to that side plus 1. So m is greater than 1. So if m is greater than 1, we will write this as 0. Otherwise, we could not write as 0. Okay. What is this? It is becoming again decreasing, decreasing, decreasing. 6 came now. Which student was absent? Every day I don't want to tell for you all this all. How much struggle you are we are taking and doing, and still you are like this doing. It should not be good, right? Anyhow, today who are absent now, those all names will be shared in the group. Let school management also knows about you all. Then that will be the better. M minus 1 is greater than 0. That implies m is greater than 1. So now what we'll do here, it is second one, right hand derivative, that is equal to limit h tends to 0. Directly I am writing here. Previously 0 minus h. Now if it is right hand derivative means 0 plus h. So f of 0 plus h minus f of 0 upon h. So just substitute h in this place. So h power n cos 1 upon h minus 0 upon h, because we know that f of 0 as 0. So now equal to limit h tends to 0. So now what we need to do here, it is anything subtracted with 0, we get the same number. So now that is equal to limit h tends to 0, h power m cos 1 upon h. So a power m upon a power m upon a power n, that is here nothing is there means 1. So a power m minus 1. So that is limit h tends to 0, h power m minus 1 cos of 1 upon h. So that is equal to what we can write now. So after this, we can write this as just remove this limit and substitute there 0. Okay. When you do that, 0 power m minus 1 into cos 1 upon h. If directly I'm writing, previously I showed how it is when m is greater than 1. So now I'll write if m is greater than 1, then that is equal to becomes this as 0. So here h naught it is 0. So now here m is greater than 1, this becomes as 0 and this gives us equation number, so previous one where, so here it is equation number 1, this is equation number 2. Right from 1 and 2, LHD is equal to RHD. Therefore, f of x is differentiable at x is equal to 0, where m is greater than 1. So we proved, so first it is continuous when m is greater than 0, then m is greater than 1 when it is differentiable. Okay, so that is about your problem number 7. You have any doubt, you can ask me. If you are not having doubt, we'll carry on, we'll continue. Firstly we'll complete. Today we have to complete this total exercise, and so that we'll complete this chapter today itself. Right? No doubt, sir. Okay, we'll complete now. So now 8th problem. Then 9, 10, 11. So important one is your 11th. Right. So now your problem number 8. So 8th one is very easy, so that I don't want to explain to you, because when you solve that left hand derivative, you get infinite. When you get infinite, so you already know that according to the property of differentiability, we know that 3 points in that place, left hand derivative or right hand derivative, any one is infinite, then we can say that it is not differentiable. So that 8th do as a homework. And anyhow, these all solutions will be available in the description link within tomorrow. Not today, within tomorrow, because already it was done. Just I need to scan and keep. So 9th also easy, because 9th also left hand derivative you are going to get as infinite. So directly we can say that it is not differentiable at x is equal to 0. And let me check 10th one. Okay, 10th I need to explain. So 10 and 11 I will explain. So 8th and 9th do as a homework, because only left hand derivative you have to solve. Okay. So everyone is accepted that 8th and 9th as homework do, because left hand derivative only you are going to get as a infinite. When you get infinite, directly you can say that LHD is infinite, therefore it is not differentiable. Okay. Okay, so now if you have said okay, then I go for our 10th problem and 11th problem. Both are, see, this 10th also important only. Previous years they were asked. 10th and 11th both are important. Okay. Yes. So now we are going to the 10th one. If anyone absent, they will pay penalty for that, because so they cannot understand after the function f of x for differentiability at x is equal to pi upon 2, and x is equal to pi upon 2, and your f of x is equal to 1 plus sin x, and another 2 plus x minus pi upon 2 whole square. Here 0 is less than x is less than pi upon. So that means here this is your RHD, this is going to be your LHD. Okay. So functions first we kept here. This is your left hand derivative and this is your right hand derivative. That we need to solve now. So somebody was written answer also. It is So two now it is, yes, two problems we have to complete, then it is going to be completed. Okay. So right. So now we are going to solve this. First we'll go for left hand derivative. Before going to that, at x is equal to pi upon 2, f of pi upon 2 we need to find. Okay. So here x is equal to pi upon 2 this only. That means function is this. So in this place you have to substitute wherever x is there pi upon 2. Okay. So then we can write here it is 2 plus x is nothing but pi upon 2 minus pi upon 2 whole square. Pi upon 2 minus pi upon 2 is becomes as 0. 0 square is nothing but here 2 plus 0 square. 2 plus 0 that is nothing but 2. So somebody was said this answer may be the 2. Okay. So next one here left hand derivative. So we can write this as f of pi upon 2 minus h minus f of pi upon 2 upon minus h. This is your formula. So now here it is pi upon 2 minus h, where I need to substitute left hand derivative means first or second. You already know that it is first one. So in this place, wherever x is there, substitute this. So what will write 1 plus sine x means pi upon 2 minus h minus f of pi upon 2, you got answer as 2. So that is upon minus h limit h tends to 0. That is equal to limit h tends to 0. Sine pi upon 2 minus theta is nothing but cos theta. So then minus 2 plus 1 is nothing but minus 1. So now we can write here it is cos theta plus what is here h cos h minus 1. So remember here sine pi upon 2 minus theta is equal to cos theta. So by using that written here. So upon minus h. Now minus sign here what it will happen limit h tends to 0. Here also minus common, when you common minus 1 minus cos h you are going to get, then minus h minus minus get cancel. So when this was happening, what we need to do here, just observe carefully. So this is equal to limit h tends to 0, 1 minus cos h upon h. See, if I solve up to here, then you are going to get it is undefined because cos 0 has become as 1. So here it is 1 minus 1, 0, 0 upon infinite something. It is not at all possible. Because of that reason, we need to go for 1 minus cos theta is equal to 2 sine square theta upon 2. This formula we need to apply. So here theta plus h is there. So we can write 2 sine square h upon 2. So now limit h tends to 0, 2 sine square h upon 2 upon h. So now observe carefully, numerator place any number is there that will come as a denominator. So what will write limit h tends to 0 sine square h upon 2 upon h upon 2. But here observe, here square is there, here only h upon 2 is there. Here also I want this as square. What we need to do is multiply here with h upon 2. Here also multiply with h upon 2. Then what we get? Limit h tends to 0 sine square h upon 2, that is upon h upon 2 whole square into here h upon 2 left. So right. Now take limits separately, you get your answer. So let me rub this part now. Where is my test? I'll rub this part now. So in offline you will available for your notes purpose this solve. So now here it is, that is equal to limit h tends to 0 sine h upon 2 upon h upon 2 whole square. This first one. Second one, sine limit h tends to 0 h upon 2. So now what will happen? This becomes 1 into, then here 0 we need to substitute 0 upon 2, that is nothing but 1 into 0, that is nothing but 0. Clear now? So now we got, now here it is LHD. Now we need to go for Okay, Priyanshi. So now we are going for RHD. See, it is live normal class means I can able to see your faces and I can say if you are not understanding then again repetition. But here it is online class. I could not know your face feelings. That's the reason I was explaining in this way. Okay, no problem. So now we can write limit h tends to 0 f of pi upon 2 plus h minus f of pi upon 2 upon h. This only. So now you know that pi upon 2 plus h means, see it is RHD means this one, second one. So in this place, wherever x is there, substitute pi upon 2 plus h. So what will happen? Check now. 2 plus x means pi upon 2 plus h. So write pi upon 2 plus h minus pi upon 2 whole square minus f of pi upon 2 you got answer as 2 previously upon h limit h tends to 0 minus 2 plus 2 get cancelled pi upon 2 minus pi upon 2 get cancelled you get limit h tends to 0 h square upon h and square get cancelled limit h tends to 0 h that is remove h and substitute then 0 you are going to get this as your equation number 2 previous one as equation number 1 so from 1 and 2 so at last here I am writing that one therefore from 1 and 2 LHD is equal to RHD. Therefore, f of x is differentiable at x is equal to pi upon 2. Clear now? In this way, we have to solve. So both you got as 0, so that at x is equal to pi upon 2, we can say these both are equal. Therefore, it is a differentiable at x is equal to pi upon 2. I hope you all understood this and we'll go for last problem. I think it is very easy. Tell to me fastly. You are okay? No clear? Yes, sir. Okay. So now we are going for the last. This is important problem. 10th and 11th are important problems. Previous years they were given. So you have to concentrate on those more and more. Even your problem number 7. So now your last problem of today and for this chapter. Find the value of m and n. Find the value of m and n if function f of x is equal to x square plus 3x plus m and x plus 2 when x is less than or equal to 1 when x is greater than 1. Is differentiable at every point. So here you have to remember what is meaning of differentiable at every point. Differentiable at every point they were given means that is continuous and then differentiable. Okay, means function is continuous and function is differentiable. When they were given that differentiable at every point, remember that point. Okay. So here given as a differentiable at every point, that means they were given that f of 0. So it is given f of 0 is equal to f of 0 minus, sorry, here it is at x is equal to 1. So we can write here f of 1, f of 1 minus 0 is equal to f of 1 plus 0. So since they given as a differentiable at every point. Same method, left hand derivative is equal to right hand derivative. Again, since differentiable at every point. Okay. So these two, see, when you solve this first one, you get one equation. When you solve second one, you get one more equation. Two equations total you get. When you solve it, you get m value and n value. So how to solve? Just observe. First find f of 1. So I'm going for this first one. F of 1 means they already given equal to 1 means this is your equation. So wherever x is there, substitute 1. So now we can write 1 square plus 3 into x is nothing but 1 plus m. So f of 1 is equal to 1 plus 3 plus m. F of 1 is equal to 4 plus m. So that is your first one. Then go for your right hand derivative or left hand derivative. Let me see for that. So left hand derivative, when you solve, you will get as 4 plus m only, so that there is no helpful for that. So that we'll go for right hand limit. See here, m value came. In n value, I need one more equation. That's the reason we are not going for left hand derivative. We are going for right hand derivative here. So now right hand limit. Right hand limit means f of 1 plus 0. So f of 1 plus 0 is equal to limit h tends to 0 f of 1 plus h. So now wherever x is there, substitute 1 plus h. Right hand means this one, nx plus 2. So n into x means here 1 plus h. So right here 1 plus h plus 2. So that is limit h tends to 0. Remove this limit and wherever h is there, substitute 0. N into 1 plus 0 plus 2. So you get as n plus 2. So, but we know that these both are equal. So, let me give that equation number 1, equation number 2. These both are equal according to the given condition. So, 1 is equal to 2. We know that 1 is equal to 2. That means 4 plus m is equal to n plus 2. So, we can write this as m minus n is equal to 2 minus 4. M minus n is equal to 2 minus 4 is nothing but minus 2. Okay. Don't worry, Himanshu. So, okay, I was understood your problem. So, it's okay, no problem. So, that is about your problem number 11, first part. So, now, first part, we got one equation m minus n is equal to minus 2. And now we'll go for second part. Second part is LHD. Go for LHD first. LHD means you already know that limit h tends to 0 here for 1. So f of 1 minus h minus f of 1 upon minus h. This is your formula. Then 1 minus h, the left hand derivative. Which is here left hand derivative? You can check. Less than is there, that is left hand derivative. Greater than 1 is called right hand derivative. So in this place, substitute 1 minus h. Wherever x is there, substitute 1 h. So x place now we are substituting h plus m. Okay. Okay, don't worry, Himanshu. So now let me complete this. I hope so. If it is not possible, you can go that another video. That is offline video. Okay. So now here it is 1 minus h whole square plus 3 into x means 1 minus h plus m minus f of 1 means what do you know? F of 1 we already found, right? What is that? 4 plus m. So substitute that. 4 plus m. So bracket upon minus h limit h tends to 0. So when you solve this, what we need to do is just here 1 minus h whole square, a minus b whole square formula, limit h tends to 0, 1 plus h square minus 2h plus 3 into 1, 3 minus 3h plus m minus 4 minus m upon minus h. Now check any cancellation possible. Minus m plus m get cancelled. Now 1 plus 3 is 4 and minus 4 get cancelled. So now here what is h square minus 5h. So this part I'll rub. So you got here it is that is equal to limit h tends to 0. So anyhow, first equation you got as m plus 4. Sorry, m minus n is equal to minus 2. Okay, no problem. So limit h tends to 0, h square minus 2h minus 3h means you will get as minus 5h upon minus h. I hope so within the time I'm able to complete, don't worry. So now what I can write in this place, common here h. So when you common, what you get? Limit h tends to 0, h common, h minus 5 upon minus h. H get cancelled. Wherever limit h is there, substitute 0. Now limit remove 0 minus 5 and here minus symbol. So now you can get as 5. So now here you got as 5. Now go for your RHD. Limit h tends to 0, f of 1 plus h minus f of 1 upon h. So now right hand derivative means nx plus 2. So wherever x is there, substitute 1 plus h. So now n into 1 plus h plus 2 minus f of 1 means you already know that f of 1 has 4 plus m upon here h is there, right as it is h. So that is equal to limit h tends to 0. Okay. So now next part I'm going to write in this place. Because this is equal to limit h tends to 0 n into 1 n minus comes to a plus 2. So this is equal to n is equal to m plus 2. So wherever n is there in this place, substitute m plus 2. So limit h tends to 0, m plus 2 plus nh plus 2 minus 4 plus m upon here h is left and here also h. Limit h tends to 0, m plus 2 plus 2, 4 plus nh minus 4 plus m. So now plus 4 plus m plus 4 minus m plus 4 get cancelled. So now what is going to be left? That is equal to limit h tends to 0, nh upon h get cancelled. At last you get answer as n. So now if you we cannot substitute h value here, so we get at last answer as n. We know that here this part I am going to rub now. Here what do you know? We know that LHD is equal to RHD. LHD is how much you got? So left hand derivative you got as 5. And what is your RHD? RHD you got as n. So what is your answer? N is equal to 5 you got. Substitute this n is equal to 5 in this equation. So let me give this as equation number 1. So in 1, so n is equal to 5 in 1. 5 is equal to m plus 2. M plus 2 comes to here minus 2. 5 minus 2 is equal to m. M is equal to 3. So in this way we are going to get at last our answers are therefore m is equal to 3, n is equal to 5. So here understand clearly. The first one it is when you solve this one you are going to get as equation number 1. When you solve LHD equal to RHD you are going to get another equation. There itself you are going to get your values. So at last we found m is equal to 3, n is equal to 5. You all understood this? So that is about your 11th problem, and this problem is very, very important. What you want to do is, if still anyone having any doubt in this, just go through your offline videos, pause it and learn one by one, step by one step, so that you can understand clearly. Okay. So what is Himanshu? 3, 5 is what? Okay, you are saying the values. Very good. So I hope you all understood this. Priyanshi is next. Okay, so you all saying Priyanshi is next Vakuntala Devi. Yes, maybe we may expect that. So, all right, one more thing today I want to tell to you. See, first we are going to complete all the easiest chapters, then we'll go for continuation ones. Those are differentiability, integration, and those are continuity chapters. So, next we are going to discuss vectors chapters. So, vectors, and another one it was 3D geometry. Once that is also completed, then we are going for our probability. So all three are completed. Maximum chapters in your book are completed. Means all easiest ones are completed. Then we'll go for continuity chapters. So differentiation, integration, those are not difficult. You have to remember those all formulas. So when you go for those all things, then you are able to get your good marks. So first, in these 10 chapters, you have to concentrate more and more. Now it is the sixth one, but that one was already completed LPP, 7, and then vectors chapters are 2, 8, 9, probability 1, 10. The 10 chapters you should be thorough. Okay? Okay. Mega you all. Thank you, one and all.